Happy Friday. Welcome to physics. Today, you have hopefully a quick activity, which is going to be our motion post assessment. You might remember at the very beginning of the year, we did a little pre assessment, and a lot of people were like, "Oh, what is this?" And that's kind of the whole point, right? You haven't learned it yet, but now uh, this is the same test for the most part. I changed the last question. Um, but hopefully you'll feel better about it. So we'll see how it goes, and that it'll show that we've learned something this the last few weeks. So if you open today's agenda, you'll see it here. I'm uploading the video right now, and so just kind of showing you the pre-assessment real quick, or the post-assessment real quick. Again, answer all the following questions to the best of your ability, and do your best to show your work so that I can give you partial credit. Okay. Problem one. Okay, this scenario should look very familiar. Take a safe route that Mr. Martin rides a bicycle from downtown Hillsborough to Aloha High School, taking a safe route that measures 13.5 kilometers. It takes him exactly 30 minutes. Okay, what is his average velocity in kilometers per hour? So just a little hint, just a reminder, okay? You need your units of time to match. So this gave you 30 minutes. And I'm asking you to convert that to an hour. And so hopefully we know that 30 minutes is also called half an hour. And then if you can do half as a decimal, that will help you with that conversion, okay? So then show your work. So again, I can give you partial credit. Next, which of the following graphs correctly show the motion of an object with a constant velocity? Okay, so the thing with this, you really want to pay attention to, is it a velocity versus time, or is it distance versus time? Okay, most of the graphs we've talked about this year have been distance over time. Okay, so then hopefully we can kind of look at that and talk about constant velocity. And also with that, hopefully we don't get confused with the constant acceleration. Okay, this question was referring to constant velocity. Okay, so again, really make sure you pay close attention if it's velocity over time and what that graph is telling you. Which word describes a relationship between distance and time for an object with a constant acceleration? Okay, so this is what we've just been doing, constant acceleration, and we referred to one of these as the type of pattern or relationship. So hopefully those look familiar. And just a reminder, we've talked about constant velocity, and then now constant acceleration. So do your best not to mix those relationships up. Then number 4, again, this is exactly from the pre-assessment where you're given this table, and again, you can kind of zoom in, I thought. But you can also make your line a little thinner and then type in so that you have more room to type. Okay. And we've seen a chart like this, and I just want to see how many you can add for the different types of units: distance, velocity, and acceleration. And then this is our finale. I changed this up a little bit to be more appropriate to what we have covered. So you have the Steamboat Geyser in Yellowstone National Park, Wyoming, is capable of shooting its heated water up from the ground with a speed of 48 meters per second. Okay, again, with these story problems, really determine what is this value. Is it a initial velocity? Is it a final velocity? Is it acceleration? We should be able to tell based on the scenario and the units. Okay, then assuming that the rate of deceleration is negative 10 meters per second per second. Again, got a rate of acceleration there. How high can this geyser shoot? I gave us a little hint because, kind of as I promised, I wasn't really requiring that you memorize these different equations or memorize how to move the equations. So I really wanted to make sure I gave you the equation to help solve for this. Okay. And also think about when it says how high can it shoot, that's referring to a distance. Okay. Distance from the ground is what it's talking about there. And then a little uh, secondary hint. Okay, you might be thinking, well, I'm missing some information. Similar to when we've talked about like the airplane comes to a halt or the car came to a complete stop. That is a way of the scenario telling you a velocity. So this one, it's actually assumed because we're talking about how high can it get. So that's getting to the peak of its shot right up into the air. So when it gets to its peak, technically it would come to a stop before gravity brings it back down. So just I kind of wanted to help us out just a little bit with that. At the peak of this, which is also answering the question, technically the velocity would be 0 meters per second there. Okay, so that's it. Hopefully, it doesn't take you too long. Hopefully, you feel good about it, and then I hope you have a great weekend.